So I have 26 to 32 here. So let's go through it one by one. Are you ready? In 26, which of the following is the least? When they give you which of the following is the smallest, this is how you go about it. Are you ready? To the decimal place. The first number after decimal place, for instance, is, have you heard of the word called tens? This is like saying 1 over 10. And 1 over 10 is the same as 0.1. Have you heard of the word called hundreds? 100 is 1 all over 100, which is 0.01. So 1 over 1/10 is bigger than 1 over 100. And likewise, if you heard of the word called thousand, let's say here where they place it with 10 is different from tenth, where you have th. Hundredth, thousandth. Sorry, I'm not doing that phonetics here. This is a math class. So here, for thousand, we have 1 all over 1,000, which is like say 0.001. So if you want to look for which is the least, look for the one that has a placement of more zeros away from it. From the look of it, this is the biggest among them, 0.01, followed by C, followed by B, then followed by D, because it has 3 zeros before the last number. This one has 2 zeros before 2, 2 zeros before 5. That's why C is bigger than B, 0.005. This is bigger than this. But we're looking for the lowest among them. But the highest among them is this first one. So the lowest becomes what? E, because it has 4 zeros before the 9. That's the lowest among them. Look at it as the place value. 0.01 is like 1 over 100. This is 1 over, like 2 over 1,000, 5 over 1,000, 3 over 10,000, 9 over 100,000. So the answer is what? E. It might look as if it's it's not even the biggest. By logic, you should know this is the smallest. Because the question says, what is the least number? So your answer is what? E. In 27, they said the area of a rectangular sheet of paper is 49 centimeters square. You put a square centimeter, it's still the same as 49 centimeters square. If the breadth is measured as 7 over 8, what is the length of the paper? First thing first, area of rectangle, I believe you should know by now, equal to what? Length times breadth. So if we have 49 centimeters square equals to, with length we don't know, but breadth we know, because they give us breadth as 7 over 8 what? Centimeter. Are you ready? So this will give us 49 equal to 7L over 8. That means L times 7, 8 will be underneath. Length times breadth. The breadth is 7 over 8. Now, when you see this kind of fraction side by side, because of a junior class situation, you are allowed to what? Cross multiply them like this. So I think I should write this. Cross multiply the equation, because it's an equation. I told you meet equation most of the time. Area of the rectangle is 49 centimeters square. They wrote it in words, but this is the best way of writing it. This is a proper way of writing it. 49 centimeters square. The word square centimeter is still the same. So now length times 7 over 8. So when you have a fraction side by side, you cross multiply them. So you have 7L equals to 49 times 8. But right now, since you're looking for what? For L, you now what? You divide both sides by what? 7. Divide both sides by 7. I started solving from here. I said area is length times breadth. Since area is 49, length we don't know, breadth we know. So we multiplied it, but it's a fraction. There's an invisible one here. So that's why 7 has to multiply L. That's 7L over 8. So we cross multiply that. 7L times 1, 7L. 49 times 8. I don't want to multiply it because I know I must divide both sides by 7. So when I do that, I will have 7L divided by 7 equals to 49 times 8 divided by 7. So 7 will cancel 7. So L equal to 49 times 8 all over 7. And I know 7 can divide 49 also. So I will take it as 7 here 1, 7 here 7. 7 times 8 means that L equals to 7 times 8 will give me 56. And I can now place my denominator there. I remove the denominator so I don't, all this centimeter square, I remove them so I don't cause confusion. So the length is 56 centimeter. If you look at it, it's 56 times 7 over 8, that will give you 49. If you want to check it, you can check it. Or if you want me to check for you, look at it here. The length is 56. Since you say length times breadth, 56 times, are you ready? 7 over 8 means that 8 here 1, 8 here 7. 7 times 7 equals to what? 49. So that's the way you go about it. They'll give you the area. They will expect you to get the length or the breadth in some cases. Exactly. So let's check. E is the answer to this 26. But because I did not write the option for 27, I think 27 will give us option D, 56 centimeter. The option is D. The option there is D. In my own 23rd edition, the answer, option is D. Are you there? Okay, still on a friendly note. Find by factor the square root of 576. There's nothing difficult here. You start wondering, square root of 576, how do they expect us to get it? It's not hard. Just be calm. Do this. Are you ready? To find the square root of a number using factor method, break the number using the prime factors. 576. Let's try and see whether this number can. Okay, let's see. What's the first prime number they use in dividing? 2. Let's start with 2. 2 here. 2 in 5 is 2. Remainder 1. That's 17. 17 divided by 2 should give us about 8, which is 16. Remainder 1. I said 5 divided by 2 is 2. Remainder 1. 17 divided by 2 is 8. That's 8 times 2 is 16. There's a remainder of 1 also. So we add the remainder 1 here. 16 divided by 2 is 8. We continue again. 2 here, 144. 2 here, 72. 2 here, 36. 2 here, 18. 2 here, 9. 3 here, 3. And 3 here, 1. Okay, now you want to know what the square root of these numbers are. After you finish dividing here, take them in pairs. 2, 2, 2, and 3. So what you do is this. You say 2 times these two pairs becomes a 2. These 2 pairs becomes a 2 times another what? 2 times another what? 3. I don't want confusion here. So better still, I think I should do this and write it out completely. Are you ready? That means that therefore, the square root of 576 equal to, ready? This is 2 square root of 2 raised to the power of 1, 2, 3, 4, 5, 6 times 3 raised to the power of what? 2. If you multiply 2 times 2 times 2 times 2 times 2 in 6 places times this 3 and 3, which is 9, you will get 576. But the truth is this. The square root of a number, for instance, they give you square root of 2 raised to the power of 2. The answer is 2 raised to the power of 1. If they give you square root of 2 raised to the power of 8, the answer is 2 raised to the power of 4. The square root will divide the power by 2. That's the meaning. Now, in this case, this will become 2 raised to the power of 3 times 3 raised to the power of 1. Wow, what's 2 raised to the power of 3? What is 2 raised to the power of 3? This is 8 times 3. 2 raised to the power of 3 is 2 times 2 times 2. Don't call it 6. 2 raised to the power of 3 is not 6. If somebody gives you 2 raised to the power of 3, know this is 2 times 2 times 2, which is what? 8. Is that clear? And 3 raised to the power of 2 is not 6. It is 3 times 3, which is 9. So what you're going to have will be 8 times 3. Remember, this power would divide to give us 1. This power would divide to give us 3 because of the root sign. Now that the root sign is gone, you cannot tell them that the answer is what? 24. It is 24 times 24 that will give you what? 576. But if this is confusing, because you're going to meet this in JSS1 also, this is the best possible way of solving it. But because for simplicity, for a junior class like yourself, where you want to work very fast and smart too, it's an examination. There is a lot of exams on board, Nigerian Army, Navy, and the rest of them. You also have the Catholic schools too. They bring their questions in this aggressive way towards you. So whenever they ask you to look for square root of a number using factor method, break the number down with prime factors. That method I was trying to use then initially was this. Carry 2 pairs like this and make it become 1, 2. Times it with, you have, as far as the number is a perfect square. What I mean by perfect square? A number that have a whole number square root. What are your perfect square? 4, 9, 16. If you look for square root of 4, it's 2. Square root of 9 is 3. Square root of 16 is 4. Square root of 25 is 5. 4, 9, 16, 25, 36, 49, they are perfect squares. So I will use the word perfect squares. Every perfect square, you must have a situation where you have pairs of the numbers you use in dividing them. Which means that take this pair as 1, 2, this pair as another 2, this pair as another 2. Are you saying that 2 times 2 times 2, which is 8? Then this last 3 pair, this one that is, this 3, that's a pair, times it again by 3. Then you get your answer, which is going to be 2 times 2 times 2 times 3. 2 times 2 is 4, 4 times 2 is 8, 8 times 3 will still give us 24. If you don't want to go with this method, but I think it's simple. This 2 raised to the power of 6 times 3 raised to the power of 2. If you will get rid of the root sign, divide the power by 2. Divide this power by 2, you get 2 raised to the power of 3. Divide this power by 2, you get 3 raised to the power of 1. 2 raised to the power of 3 is the same as 8. 3 raised to the power of 1 is the same as 3, so you get it. So whichever method you want to use, you're free to use it. So when they say find the square root of, by factor method, find the square root of 1,700, just break those numbers down using the prime numbers. Don't use 4. Don't use 6. Use prime numbers 2, 3, 5, 7, 11, 13, and so on. And take them in pairs like this, and you will get your answer. Are we good? Which, if you look at it, this is the same as saying 2 times 2 times 2 times 3, which is still the same as 24. Any of the method is accepted. Now, 29. John and Peter ran a 100-meter race. I'm reading this 29 now. Please join me here. They both started at the same time, but Peter started 10 meters in front of John. Okay, this is John, and this is Peter. So they started at the same time. So this is John's position, this is Peter's position, and what we have between them is 10 meters. Between here and here is 10 meters. So Peter is ahead of John. That means John is a fast runner. This is John here, and this is Peter. And they have to cover a total of what? 100 meters. Between this spot and this finish line, you know you have 90 meters remaining. Okay, so now John and Peter ran a 100-meter race. They both started at the same time, but Peter started 10 meters in front of John. So let's now say the whole of this line is a start point. This is where they're supposed to start, and this is where they're supposed to end. So that means the whole of this from here to this spot should be 100 meters. Let's look at it like this. From here. This is where they start from. This is where they end. Now, then I said, Peter started 10 meters in front of John. Now, Peter is 10 meters ahead. So that means between John and Peter, that's 10 meters. And that means you have about 90 meters left to the end of the race. Like this. Okay. Now, then I said, John won by 13 meters. Despite John was behind, he won by 13 meters. That means when John was here, are you ready? Then, if this was John at the end of the race, then Peter will be somewhere around here. And if you look at it, if they won by 13 meters, that means we have 13 meters here in between John and Peter at the end of the race. This is the end of the race. Now the question is this: what distance had Peter run when John finished? If Peter was here already 10, are you listening? And by the time you know you have a 90 between Peter to the end of the race is 90. Please, it's very simple. You just draw the diagram, you will get it. If you don't draw the diagram, you might not find it easy to get. For Peter to get to the end of the race is 90 meters. By the time John actually finished, he was, according to them, they said, John won by 13 meters. That means when John finished, Peter was somewhere around here. So how do you know? Peter had to actually cover 90 meters. So what we'll do is to say 90 minus 13. That should give us, add one here, 10. 10 minus 7, minus 3 is 7. 8 minus 1 should give us about 7. So that means Peter ran 77 meters. What distance had Peter run when John finished? He did 77 meters. Because he was 10 meters ahead of John. Are you there? They are supposed to go 100-meter dash. But because John was faster, they gave Peter a 10-meter ahead start. So by the time they end the race, John ended first, he finished, but he was 13 meter, Peter was 13 meter behind. Since Peter had to go 90 meter to the end of the race, then remove the 13 meter left, then you discover the number of meter Peter ran before John got to the end of the race. So it's just as simple as that. So the answer is 77 meter. Now let's check our book, number 29. For 29, we have A. The option there is A. Most times, like this kind of situation, it is better you draw the diagram. Draw a diagram, because if you want to use your head in examination, you will not have that time. They will time you by every question. So once you start saying, John, Peter ran a 100-meter dash, let it be 100 meter. Let's say from here to here, assume 100 meter. They both started at the same time, but Peter started 10 meters ahead. So just be fast enough to draw a diagram like this. 10 meter, so you have a 90 left. When they say start, John ended first. But by then, he gave Peter another 30-meter distance again. So that means from that 90 that Peter was supposed to cover to the end of the race, you have to remove this 13. So that will leave you with 77 meters. I know you get this. This is easy. And let's not forget, for 28, we have 24 as the square root of 576. Did you check there? If you've not, let me confirm 28. We have 24. And that 24 is D. I actually remember then, I knew I was supposed to, but I just say, let's go ahead so I can number them for you as we go. So this is how you solve the question of 29. It looks as if the question is lengthy, but you just start with the diagram. Don't just start reading it, because in exam situation where you're tensed up, you can read this particular line 3-4 times and it will make no meaning to you. So learn to just draw diagrams and you'll find yourself doing it. Let's draw diagrams, straight lines, like case of this.